Hello everyone, hope you are doing good and welcome back to my channel. Today we are at day 13 of the Geeks problem of the day for the January month, and we have a very good question in front of us. This question, like, it may seem very easy, but it really tests your skills for how you are well versed in pointers, or let us say linked list, and for that reason anything related to those, okay, especially pointers. So let's see what it is. So it actually tests your skills in whether you know that sorting algorithm or not, and secondly it will test your skills like your expertise, whether you are able to handle pointers or whether you understand those concepts behind those pointers, like the allocation of memory locations, and like how to do it without deleting something, or without making something hangling. Okay, what hangling means, that if you lose track of a particular data space, it becomes hangling. Okay, as simple as that. We can't use it further because we don't have any pointer pointing to it. Okay, as simple as that. So in this particular question, we are asked, basically the question name is insertion sort for singly linked list. Okay, so I hope you would be knowing by now what is a linked list, because previously also in the January month we had questions for that. So I hope you are knowing that. And when we say single linked list, it basically means that there will be a single connection between any two nodes. Okay, double linked list means there will be more than one connections. It may be pointing towards something, or it may be a reverse one as well. So in this case, we are not having those things. We are simple. We are simply having a single link. Okay, from one node to another in a linked list. Okay, that's what the question is. Given the linked list, sort the list in ascending order using the insertion sort algorithm. So this question basically assumes that you know what is insertion sorting, and then it is asking you to do that. But anyway, we will again see what is insertion sorting, and then we'll come to the solution. As you can see, it's a simple, just a we are discussing example of how what happens. So insertion basically means that we are having a boundary basically, and everything to the left of the boundary is already sorted, and everything to the right of the boundary is to be sorted. That's what we are going to do. And the algorithm will complete when the whole part which is on the right will disappear and everything comes to the left. That is, everything is sorted. Let's see what it is. Initially we'll begin at 23. 23 in itself is like sorted. We'll say the first element is anyway sorted in itself. Then we'll come to 1. I will try to place 1 in the left half of it. Okay, in the left half of it, in such a way that the left half becomes sorted. How can I do that? Obviously, I can do that by placing 1 to the left of 23. Okay, that's what is being done here. Okay, as you can see this. The next element is 10. Okay, what will happen with 10 now? 10 will go between 1 and 23. In that way, it will become sorted. Okay, so please try to understand what we are doing. We are taking one element from the right half. See, in this case, the right half is 10 5 2, right? We'll take the very next element in the right half, and in that, and then we will try to place it in a one particular location, such that the whole left half is sorted. As you can see, 10 is placed between 1 and 23. That's what it is. And same, the next element is 5 now, where 5 will be placed. 5 will be placed between 1 and 5, and so on. Okay, this process will continue till we place the last element in such a way that the whole left half becomes sorted. So that is the basic idea behind this insertion sort. Okay, so basically, this is a just I googled it and got this article. So credit goes to the medium source. Okay. So now coming to our question, what we can do? See, again, same thing I'm going to use. So, but just try to understand what all we need for this. See, try to understand this part. The green part which you are seeing here in the right of your screen. Okay, this part is basically a region in which everything is sorted. Okay, so how to keep track of this region? So for this, we will need two pointers, which will be pointing to the start and which will be pointing to the end of the region. Okay, that is one thing. Now we will need another pointer to point to the very first element of the right half. Okay, which is 10 in this case, 5 in this case, and so on. Okay, so as you might be thinking, it will be easy because once we have the pointer for 23, the very next element will be the element in the one which is going to process next. Okay, so that is again there. So we will be needing these pointers. Okay, and one more thing to try to understand here. For example, if I have to place 5, okay, in the left half, what I need to do, I basically need to start a loop which will go through each of these elements, and it will find the first element for which it is less than it. Okay, for example, whether 5 is less than 1, no. Whether 5 is less than 10, yes. So if it finds a very first element for which it is less than that, then we'll have to stop that search. Okay, for example, take the case of 2 here. 2, is 2 less than 1? That is not the case. Is 2 less than 5? Yes, 2 is less than 5. So stop it. Okay, don't need to proceed further. What we'll do, we'll try to place 2 ahead of 2, that we'll try to place 2 ahead of 5, and before that is, yeah, ahead of 5 and after 1. Okay, that's what we need to do. So please try to understand the logic here itself, so that it becomes easy for you to understand the coding part. See, 2, first of all I will search and I will try to find a number, for which 2 is less than that. Okay, 2 is less than that. Okay, that is fine. So in this case, 5 is that number. Now if you try to think in a linked list way, what all we need now? So we'll try to make links, with that. Okay, that is 2 should point to 5 now, and simply 1 should point to 2 now. Okay, so for that I definitely require a pointer here. Okay, I definitely require a pointer at 5. Why I require a pointer at 5? Because I have to make the next of 2 point to 5, right? For that I need a pointer at 5, and the same time I need a pointer to the element previous of 1. Okay, that is previous of 5, which is 1. Why? Because try to understand this fact. The next of 1 will be 2, and the next of 2 should be 5. That is how I should be making it. Okay, because try to understand the fact here. They are asking you to do in O of 1 space. Okay, it is possible only when you are manipulating the existing elements. Okay, without allocating any new space, without allocating any new you know ma- without using any new members of the node class. You have to use the existing members and the existing space allotted to them, and you have to simply change the pointers, okay, to where it is pointing, is in order to arrange them in such a way that they are sorted. Okay, that's what we need to do. So I hope you understood my explanation, and the same I'm going to show in the code. Okay, if you have not understood this part, please pause the video again, rewind, and please try to play it again. I have explained the whole part here. If you understand this part, I am sure you will understand the code as well. Okay, so here comes the coding part. It's a edge case where if the head is none, because you try to see the n can be 0 as well. Okay, the length of the linked list can be 0 as well. So for that reason, we no need to dig our head much. What we need to do is simply see if head is none, simply return head. Okay, simply return none. That's the basic idea. As I mentioned, we need 2 pointers basically to mark the sorted region. For that, I'm using 2 pointers, which is end. Okay, and it will point to the end of the sorted region. Okay, it will point to the last element of the sorted region, and head is already given to us. It will point to the first element of the sorted region. Okay, so initially end and head will be pointing to the same thing. Okay, as simple as that. Next, I will need a pointer called nex double t. Okay, what is this nex double t? It will always be the first element. You know, in the right half, okay, which is to be sorted next. Okay, for example, in this case 10 is the one. Okay, I will need to place 10 next. In the next step, I will need to place 10 in a position such that the left half is sorted. So that element will be pointed by our next. Okay, so next will always be equal to and dot next. Okay, that is the basic thing, and we are going to use 2 temporary pointers. Initially they will be none, and they will be assigned positions as per the loop. Okay, so that is the basic idea. I am declaring a print function, though it is not needed in the code. Remember, it is not needed in the code. I've only used it in order to explain you how I'm doing it. Okay, so basically it is not needed in the code. Okay, and next is this is the most important part. Remember, they are allowing of and square time complexity, and the same will be needed. Actually, there's no other way around. If you are using of one space, then you will definitely need of and square time complexity, and the same I'm also using. Let's see what it is. So what is next? By the way, next is the very next element to be sorted. Okay, for example, 10 in this case, 5 in this case. Okay, so this loop will run till next is not equal to none. Okay, that is till I don't have any element to be sorted. There is to any element to be inserted. Then remember this insertion sorted. Any element to be inserted in the sorted part, I will be continuing this loop. Okay, so initially what I will do, yeah. So basically, okay, just a second, I can remove this as well. Yeah, now it looks good. Now see here what I am doing. See, basically what I'm doing, checking is, see if this code will be executed if the very element to be placed. Okay, the next element is smaller than the starting element itself. For example, in this case, okay, 1 is the next element here in this case. Okay, 1 is smaller than the starting element itself. In that case, this code will be executed. Okay, why I'm using that you will get to know in the some time, but please wait and see. See, the idea here is it is less than head of data. What is head? Head is the first element, right? So next of data is less than or equal to head of data. Okay, that means that this particular next element, which is 1 in this case, will come to the starting now. Okay, that's what it is. So what we will do now, will the end of next. Okay, end of next, that is, and what is end, by the way, end is 23 itself. Okay, end of next equal to next of data, that is next of next. Okay, that means what will happen now, this 23 will now point towards 10. Okay, this 23 will now point towards 10. Okay, next, what I'm going to do next is next of next equal to head. What it means is, see, 1 will now point towards 23. Okay, then head equals to next. Okay, so now head will start pointing toward next. So what will happen is it will something look like this. Okay, 1 and then 23, it will be like this after this. Okay, remember this code will be executed only if the next element which we are trying to place in the sorted part, which we are trying to insert in the sorted part, is less than the first element itself. Okay, in every other case we will execute the else part. Okay, this is the else part. This is what we are trying to do here. Okay, let us go through the next part. And as I mentioned, I will be using 2 pointers. One is temp2 and one is temp1. Okay, temp 1 will be always pointing towards head, and temp 2 will be pointing towards head dot next. Why I am using two pointers? The idea here is, see, I've already explained you this. For example, see here, when I talk about 5, okay, when I talk about 5, 5 will be placed between 1 and 10, right? So I need definitely a pointer in 10, and at the same time, I definitely need a pointer in 1. Why? Because see, 1 should point towards 5 and 5 should point towards 10, right? So in that way, temp 1 in this case will point towards 1 and temp 2 will point towards 10, okay? That's why I need two pointers here. That's why I mentioned here also, always temp 1 will be the previous element of temp 2, okay? As simple as that. So this loop will continue till temp2 is not equal to end dot next, okay? The idea here is, till temp2 doesn't go to the end of the loop, the end of the linked list, this will continue, okay? If that happens, if this condition becomes true, that means the element which you are trying to insert is, the greatest element. It need not be inserted. It will always remain at the end only, okay? If that happens, then this else part will be executed. But the else part will simply end, the end of it, okay? End of the sorted part will be, extended to the very next element, okay? See, this else condition will be executed only when the element to be inserted is, greater than every element in the sorted array. That means it need not be inserted anyway, okay? That's the idea. In every other case, this part will execute it. So what is this part? I am simply trying to see, I am, rotating temp2. As you can see, temp2 is equal to temp2 dot next. I am simply rotating temp2 and try to find the element, the very first element for which our next dot data is smaller than the temp2 dot data, okay? Less than or equal to, by the way. So yeah, if that condition becomes true, until then we will execute, okay? Until then we will execute. So if that becomes true, what I need to do, again the same thing what I did here, similar thing I'm going to do now, okay? That is end dot next equal to next dot next, okay? What it means is, see, for example, in case of 5, what I am going to do now, now 23 will start pointing towards 2, okay? Because 5 is to be inserted, right? So 23 should now start pointing towards 2, okay? That is the meaning of this. Now next dot next equal to temp2, okay? Next dot next equal to temp2. What it means in this case, now 5 will start pointing towards 10, okay? That is the basic idea, okay? Next dot next equal to temp2. Yeah. Now anyway, this is the one. Now temp1 dot next equal to next, okay? So as I mentioned, temp1 is always going to the previous element to the next, okay? In this case, if you talk about this case, 1 is going to be that element. Now 1 should point towards 5. That's what it is written, okay? Now 1 should start pointing towards the next element. That is the nextd, okay? As simple as that. Once it happens, I am done and I should break out of the while loop, okay? This while loop I should break out. That's why, yeah, this is the one. That's why I'm writing a break condition here, okay? And yeah, as simple as that. Other than that, temp2 should be temp2 dot next, or temp1 should be temp1 dot next. Remember one thing, always there will always temp1 will be the previous element of temp2, okay? As simple as that. This loop will continue till then, okay? So let me quickly print and show you how it looks. The printing part I've tried to, manipulate in such a way that you are able to understand the whole picture here, okay? Try to see here. Yeah. So initially, like, this is the given array. It was as simple as the same as that. I'm printing as it is, okay? So the next element to be started is 23 in this case, okay? 23. Here is the 23, okay? The second element. So after I insert it here, okay? So 23 will come before 30, right? So it will look like this. So this is now our sorted part, okay? So what is the next element to be sorted? The next element to be sorted is 28 now, okay? So this 28 will now be inserted into the sorted part, okay? This is the sorted part initially. After inserted, it will look like this, okay? 23 will come between, that is 28 will come between 23 and 30. So it will look like this. So now this is the sorted part, okay? So what is the next element to be inserted? It is 30. Now try to understand this. 30, actually it will be inserted. For example, this 30 will be inserted before this 30, okay? Our code will do like that, okay? So it will now look like this. Yeah. So what is the next element to be sorted now? 11, okay? So our sorted part is here till now, okay? Yeah. Just a second. Yeah, till here. What is the next element? 11. 11 is to be inserted into this sorted part, okay? So where it will be inserted, it will be in the very first element, okay? So how the sorted part will look now? It will look now this, okay? So what is the next element? This is the 14. So where will 14 come? 40 will come between 11 and 23. So it will look like this somehow, okay? So they are not printing the whole output. They are saying like download the file, okay? So but I hope you have understood what it is, okay? The idea here is very simple. As I explained the whole thing to you, okay? So first we will try to find which is the very first element for which our this, for example, this 5 is less than, okay? That is 10 is the element, okay? Now I need a pointer in 10, which will be temp2, and I need a pointer to the element previous than 10, which is temp1, okay? Why I need that? Because see, 5 will start pointing towards 10, 1 will start pointing towards 5, okay? And one more thing, 23 will start pointing towards 2. If you understand at least this part, I think you will be able to code the solution. That's what I'm doing here. Okay. Okay, let me quickly run and show you after commenting out these print statements. As I already mentioned, you need not have these print functions. Actually, this whole function you can remove, because just to show you what it is, I'm doing it. Okay, so let me quickly comment out the print functions and let me quickly run and show you. So as you can see, the answers we are getting here, they are exactly matching. Okay, this is my output and this is the expected output. As you can see here, they are matching. So it was a very good question according to me, because it will test your skills, and at the same time, if you're a beginner, it will build your skills in pointers. You will have a very correct estimate of now what pointers are and how they can be used. Remember, the best part I want to highlight here is we are not using any extra space here. Okay, we are just using pointers, that we are simply pointing to elements, and we are just changing to which element it will next point to. Okay, we are not using any extra space. At the same time, we are able to solve, we're able to sort it. That is the best part of it. Okay. Yeah, if it had been an array, believe me, it will not have been possible, with over one space. Okay. If we would have done with over one space, then obviously the time code would have been much higher. But in this case, it is possible because we are having pointers. Okay, that's what it is. And if you are trying to understand pointers for the first time, let me tell you that pointers, the need came. See, pointers are comparable to arrays, right? In array, we have a fixed space. Okay, when we are declaring the array, we'll have to declare space for it. Okay, the length of it. But in pointers, that is not the case. That is a linked list is not the case. You can add as many elements as you want, provided you have that much memory in your RAM. Okay, in your the heap that is provided for your program. As simple as that. So yeah, friend, I hope you understand the solution. This, according to me, was a very good question. Please practice this kind of questions, because believe me, linked list is a very, very common topic to be asked if you are, trying for a PPO or a, full-time offer. Definitely linked list in coding interviews. I'm not saying about online assessments. Remember, in online assessment, there are many ways to cheat. Okay, you need see they are simply asking for insertion sort, but if you're doing an online assessment, there is no one to check whether you're doing insertion sort or simply you're sorting and unsetting into the elements. So that's why I'm saying in this kind of questions will only come, in the coding interview, where the interviewer will be in front of you. Okay, they will give you the question and they will ask you to, code the solution, trace it out how it works for a given example. You will have to, write the outputs and you will have to test it out. Okay, how it works. Okay, so please practice accordingly. See, solving the question is one part, explaining it is another part. That is the sole reason why I am, starting this channel, so that I can, explain you what is my thought process. Definitely try to do the same with your friends. Okay, try to explain your solution to your friends. That will increase your capacity to explain your solution. Okay, remember, the introvert may not be able to understand your explanations by looking at your code, but if you are able to explain it through, the examples, through your, explanations, then it will be added advantage. Okay, so please practice that also. See, coding is not the only thing. Soft skills always matter. Okay, so I hope you understand this particular thing, and you are, well versed with this kind of topics for pointers, which basically means the linked list. Okay, I hope you like this video. If you have any other way of doing it, okay, see, try to understand this fact. As I mentioned, there is a lot of way to do cheating. Okay, I can sort it, in an internal way, and I can simply paste the solution in the linked list. That is not the right way of doing it. See the question here. If it comes in a interview setup, coding interview, we will have to solve it exactly the way they want it. Okay, you cannot do a cheating there. Okay, if you do a cheating kind of thing there, like if you use a sort function and something like that, believe me, they will not accept that kind of solution. Okay, you will have to show this kind of solution first, and maybe after that you can say that, yeah, I know a function which can do it, on their own. Okay, so that will be added advantage only in that case. Okay, but definitely this question is to test your skill, whether you understand the insertion sort or not, and if you're able to use the linked list, that is the pointers, in a correct way to code it. So I hope you understand, and yeah, that was all for today. If you like my video, please do comment and please do subscribe to my channel. This really motivates me a lot. Thanks a lot. We'll see you tomorrow.